All right, so we are doing areas of parallelograms and triangles now, and this is 11.2 in your books. All right, let's start off with our objectives as usual. We are going to find the areas of parallelograms. We are going to find the areas of triangles, and that is it. So let's start off with a theorem. The area of a parallelogram. This is theorem 100. The area of a parallelogram is equal to the product of the base and the height. So basically, it is the same as a rectangle. I wonder why that is. Well, let's take a look at a parallelogram. Here we've got the base and the height. Okay, thing to keep in mind. This length here, okay, not the height. Pardon my writing, sloppy writing. I'm trying to write sideways. So this part here is not the height. The height is the altitude to the base. Okay. In a rectangle, since it's 90-degree angles, yes, the one side happens to be the height and the altitude. But be careful with it here. This side is not the height. The reason why is because if we were to take this and move it over here, we haven't changed the area of the figure. We've just moved it. Now look, that part that was the height, okay, is now the side of a rectangle. So it's kind of the same thing, same way of thinking about things. So let's take a look at an example with a parallelogram. We need to find the area of a parallelogram if AB equals 12 and AD equals 32. Okay, and if AD equals 32, BC is 32. So I put it up here just for the sake of it. And then the measure of angle A equals 60. Well, how are we supposed to find the height from that? Well, remember, if we drop that down, it's an altitude, which means this is a right triangle. And if this is 60 degrees, this is what kind of triangle? All right? So we've drawn the altitude in. We've created a right angle. And we can use right triangle trigger ratios to find the length of the altitude. So if this wasn't a nice number, I could use, let's see, I've got a hypotenuse and I've got a side opposite. So that sounds like we would have to use sine if I needed to. But I don't, because this is a 30, 60, 90 triangle, which means that the sides are x times root 3, and 2x. So if the hypotenuse is 2x, because that's opposite the 90, that means the side opposite the 60 is 6 root 3. Okay? So then the area would be the base times the height. The base is 32. The height is 6 times root 3. So that equals 192 root 3. Because remember, we can multiply these numbers, and this one just does not change because we don't have a radical at this one. So I got that just by multiplying 32 times 6 and kept the radical 3. So the answer for this would be 192 times the square root of 3. Now let's look at area of a triangle. We'll start this one off with a theorem also. Theorem 101 states that the area of a triangle is equal to 1/2 the product of a base and the height, or altitude for that base. Okay, so area of a triangle equals 1/2 the base times the height. So let's find the areas of these triangles. Now the base and the height, you got to go by what you have. So even if you notice here that this particular segment isn't on the bottom, that's fine. Okay, but if I know the length of that, I'm going to call that a base. So I need to find the height from that base, not from here to here. There's a difference. If I wanted to use this height in here, I would have to know what this base was. You would come up with the same answer, but in this case, let's go with what we have. All right. Okay, so the height is 10 and the base is 15. So we do half of 10 times 15, which would just be 75 square centimeters or centimeters squared, however you want to write it. All right, now with this one, notice that to get the height from the base to this, I actually have to extend the triangle out. Now, even though I'm extending it, I'm still only using this base. But the height always forms a right angle with the base. So sometimes you have to draw outside the triangle to figure it out. So we do know that the height's 8 millimeters and that the base is 7 millimeters. So we do area of a triangle equals half the base times the height. So half of 7 times 8, which would be 28 square millimeters or millimeters squared. Now, if you think that your test problem is going to be this easy, you're sorely mistaken. Sorry. They're going to be more like this. Find the area of the shaded region. Okay, so that means this area in here. All right. So first we need to find the area of the rectangle. Then we need to find the area of the triangle. Triangle is inside or inscribed in the rectangle, and it's not part of the shaded area. So we're going to find the area of the rectangle and subtract that from the area of the rectangle, which should leave us with just this. Not should, will. So let's find the area of the rectangle. Well, we've got a height of 10, a base of 17, so 17 times 10 is 170. And because this is a rectangle, that means that this base is also 17, and that the height of this triangle is 10. So all we're doing is taking half of that, half of 17 times 10, and that's going to give us 85. So we take the 170 minus 85, or the area of the shaded region is going to equal the area of the rectangle minus the area of the triangle. So that should be a 170, sorry. Minus 85 equals 85. So in this case, it's just half. So easy enough. So just keep that in mind. There's a lot of things that you have to pay attention to in this unit. The information they're giving you especially. Okay? So some key things to keep in mind is that just about any polygon can be broken down into right triangles. So if you get stuck, try doing that to see if it helps. So take, for example, if I had a rectangle. Look, 2 right triangles. Okay? Any type of triangle I draw, even if that one wasn't a right triangle, I have 2 right triangles here. Okay, square, 2 right triangles. Okay, so no matter what type of shape you draw, I guarantee you can get right triangles out of it and take up all the area. So see if that helps. That's all I'm saying. All right, videos will keep coming, but this unit will be going a little slower, as I've said before. So take your time, ask questions if you get stuck. We have plenty of time to get things straightened out.